Welcome back, everyone. We are doing another Go Math video. I apologize in advance if you hear any noises in the background. It is pretty stormy tonight, so we got some crazy sounds going on in the background. Today we're going to be comparing fractions with common denominators and common numerators, a concept that we've gone over before, but we're going to go a little bit more in depth. And we've obviously compared fractions. We did in our last video with benchmark fractions. So today's just another step forward. It's honestly a more standard way of comparing fractions. It's one of the easier ways to compare fractions. So that's what we're going to do. So we're going to dive right into it. Don't mind my erasers here. Let's go ahead and erase that. And let's get started. So if I have two fractions, and let's say they are 3/8 and 1/4. By the way, quick pause. This video goes along with Go Math Lesson 6.7 on page 263 in the 4th grade Go Math book. So if you want to follow along, you can go to page 263, Lesson 6.7, and follow along. This is on that page. Okay, so we have the fractions 3/8 and 1/4, and we're looking to compare them. So using benchmark fractions, we could do this, like we did in our last video. However, today we are going to find common denominators and common numerators. So again, a little refresher, denominator is the number on the bottom of the fraction, the numerator is the number on the top. The first way we're going to start with is common numerators, or sorry, not common numerators, common denominators. We're starting with the bottom numbers. So the way this is going to look is we are going to take the fraction 1/4, and the reason why I'm taking 1/4 is because I know that 8 is a multiple of 4, so this fraction we're not even going to touch. But we're going to change 1/4, so I'm going to do 1/4 times, and to get that bottom, I'm going to get this bottom number to equal 8, I'm going to do 4 times 2. However, to make sure my fraction doesn't change, the size of it doesn't change, whatever I do to the bottom, I have to do to the top. The reason is because I'm multiplying by a whole number. Because remember, 2/2 equals 1. And 1 times anything, that number that you multiply times 1 stays exactly the same. So even though the numbers are changing, the size of our pieces and such still stay the same. So we're going to do 4 times 2. That is equal to 8. And 1 times 2 is equal to 2. So now, our new problem is 3/8 compared to 2/8. Now, because our denominators are the same, we're just going to focus on the top numbers and see which one is the bigger number. Now, because 3 is bigger than 2, 3/8 is greater than 2/8. So we can go back up to the top here and mark in that 3/8 is greater than 1/4, because this problem and this problem are both the same. Now, if I wanted to double check and really make sure that this is correct, here's what I would do. First thing I would do is make some space on your whiteboard here. So I'm going to leave this problem right here. So I'm going to leave the 3/8. Actually, let's do this. No, actually, that's good. That's good. We're going to leave the 3/8 and compared to 1/4 and 3/8 compared to 2/8. And I'm going to show you how this works. So I'm going to draw this shape, and I cut it into 8s. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And I'm going to shade in 3 of them. So here we have 1, 2, 3/8. This shape right here can be represented on both sides, both 3/8. I'm going to draw another one. Here, let's draw the little comparison thing too. And then I will draw 1/4. Now, in a perfect world, these boxes would look exactly the same. I don't have that capability because, it requires drawing, and I can only draw so well. So instead, they're going to be somewhat similar, but again, perfect world, they're exactly the same size. I'm going to cut this into 4ths. And then I'm going to shade this in. Now, it can be a little deceiving. It can be like, I'm not 100% sure. I wonder if it is. If this is bigger or this is bigger. Well, guess what? If I were to cut this into eighths, like I did, so remember, this used to be fourths. Now we're cutting it into eighths. 1, 2, 3, 4, 5, 6, 7, 8. 8 total pieces. We can see this only has 2 of 8 pieces shaded, and this one has 3 of 8 pieces shaded, confirming that 3/8 is in fact greater than 1/4. And just like that, you solved one problem using common denominators. And you can do that with any problem, as long as you get the denominators to be the same number. Again, you can't magically make them the same number, but if you use multiplication and you multiply them by a whole, like we did right here, so we did times 2 over 2. 2 over 2 is equal to 1. As long as you're multiplying by a whole number, your fractions will turn out, or your comparisons will turn out correct. So now that we've done common denominators, I'm going to show you how we can do common numerators, and this one's going to be a little bit different. It might even be a little more confusing, but I promise you it will make sense. So let's go ahead and make this go away. Just like that. And now we're going to find common numerators. So again, we already know the answer to our comparison problem. We know it's 3/8 compared to 1/4. We already know 3/8 is greater than 1/4. But let me show you how common numerators can actually help us. So again, common denominators are making the bottom numbers the same. With common numerators, we're going to make the top numbers the same. So because this number is 3 and this number is 1, we're going to leave this 3 just like it is. So again, we're not touching this 3/8. 3/8 can stay. So let's go ahead and put a 3/8 down here, just like we did last time, compared to, and let's see what we're going to compare it to. So 1/4. I need to get this to have a 3 on top. So what I'm going to do is I'm going to take 1/4 and multiply by 3, because I want this top number to be 3, and 3 times 1 is equal to 3. So I'm going to multiply by, oops, that's a 2. I'm going to multiply by 3. And again, whatever I do to the top, I have to do to the bottom. Same concept applies for common numerators. So we're doing 1/4 times 3 over 3. And then we go ahead and do our equals. 1 times 3 equals 3. And 4 times 3 equals 12. So now we have 3/8 compared to 3/12. Now the way this works, when your numerator is the same and your denominators are different, whatever number has the bigger denominator, sorry, you can't see me pointing, whatever number has the bigger denominator is actually the smaller fraction, okay? And I know that goes against what people normally think, but let me show you. So in this case, again, we know 3/8 compared to 3/12 is 3/8 is greater than, because we already know 3/8 is greater than 1/4. We already figured that in the last problem, but let me show you how. So again, I'm going to cut this into eighths. I'm going to draw these boxes as equal as possible. That's not too bad. So let's go ahead and do 8 boxes. And let's do the top row this time. Let's try to make them all on the top. Okay? And now, again, we have this in fourths. And then we cut our fourths into 12 pieces. So let's see how I'm going to do this. I might have to go 1, 2, 3, 4. It's gonna have to be something like this. No, that's not right. I can do this better. Hang on. Let's do this and make sure we get it right. So let's cut it into 1, 2, let's cut it into 4 pieces this way. Okay? Now, there we go. Cut it into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The way I was drawing it wasn't working out. So if we were to color in these 3 boxes, we can see, I know it's a little bit hard because my drawing isn't phenomenal, but we can see, and if you're following along in the Go Math book, they already have these models drawn for you, so it's a little bit easier to tell. We can see that these 3 boxes are larger than these 3 boxes. So because of that, this is the greater fraction. These ones take up more space. Because out of the 8 boxes here, there's 3 gone already, while there's only 3 gone out of 12 boxes. So again, the bigger fraction has smaller pieces, so this 3 is worth less than this 3, because these 3 is bigger. A little bit more confusing, but again, when working with common numerators, just know that the bigger denominator, once you have the common numerators, the bigger denominator is the smaller fraction. My suggestion, though, would be to continue to use common denominators. If this works for you, then do this. But honestly, I believe common denominators is just a simpler way of going about doing this. So to make sure that we feel comfortable and confident, I'm going to do one more with common denominators. So this one that you're going to see me do will be on page 264, and it's going to be part A. In the book, it asks you to explain your reasoning. I'll kind of explain my reasoning as I go over it, but I'm not going to write an answer. I'm simply going to solve the problem. So the question is 3/4 compared to 1/3. And this is a perfect example because now we don't have a number that we're going to keep, so we're going to have to make some changes on both sides. So starting us off, let's go ahead and list the multiples of both these numbers so we know what we're going to be working with. So we know what we want as our common denominator. So I'm going to start with the multiples of 4. Multiples of 4, we have 4, 8, 12, 16, 20. That's 5 multiples. That's more than enough, more than what we'll need. So let's go ahead and do multiples of 3 now. We have 3, 6, 9, 12, and right there I'm going to stop because I see both these numbers have a 12. I'm going to make that my common denominator because I want the smallest multiple I can find, the least common multiple as my common denominator. So now we have to do some multiplication. So let's go ahead and bring this camera down for a second, and we are going to do 3/4 times 3/3, because 4 times 3 is 12, and it's also our third multiple. And then because we're doing multiplying times 3 to the bottom, we have to multiply 3 times to the top. So we get 9/12. Now, I'm going to do the same thing for 3. Or not for 3, I'm sorry, for 1/3. We're going to multiply times 4/4. Once again, it's 1, 2, 3, 4th multiple. 3 times 4 equals 12. We already know that from over here. And whatever we do to the bottom, we do to the top. So 4 times 1 equals 4. 3 times 4 equals 12. We get 4/12. So we really have a comparison problem that says 9/12 compared to 4/12. With that problem, we know that 9/12 is greater than 4/12. If we go back up to the top, 3/4 was equal to 9/12, and 1/3 was equal to 4/12. So 3/4 is greater than 1/3. Now, if you'll notice something here, one last thing I want to point out before we go ahead and end this video is our numbers that we multiplied with were actually both the denominators. So we multiplied 3/4 times this denominator, which was 3, and we multiplied 1/3 times 4, which was this denominator. One thing you can do to find common denominators, if the numbers are small enough, is you can just multiply the denominators together and then compare fractions that way. That's a totally fine strategy if you want to do that. Sometimes the numbers get a little big and a little bit harder to work with, which is why we don't always do that. But it's a little shortcut if you are struggling with finding your common multiple. So with that being said, that is all we're doing today. We're just comparing fractions using common denominators and common numerators. And hopefully you learned something from this video, and I look forward to doing another one for you in the future. See you later.